All right, this is the 6th FRQ for the 2017 BC exam. So first they're asking you to see that this is a Maclaurin series and these are the first 4 terms, and they want you to take this information and show that these are the terms that you would get, and then they also want you to write the general term of that series. So I'm going to go ahead. Now, I usually like to list out what I have, so I'm just going to say f of 0 is 0, f prime of 0 is 1, they gave that information to us, f double prime of 0, and then it says, so f double prime is the second derivative, right? That's 1 plus 1. So that means that your n value, even though you're looking at the second derivative, your n value is 1. So that's going to be -1 times the first derivative. So -1 times the first derivative. And so that's -1 times 1, which is -1. Then for the third derivative, the third derivative would be 2 plus 1. And so that means n is 2. So we have -2 times the second derivative. Which is -2 times -1, which is +2. And then the fourth derivative is going to be 3 plus 1, and so this is -3 times the third derivative. So -3 times 2 is -6. Okay, so then to make the Maclaurin polynomial, we would have 0 plus 1x minus 1x squared over 2 factorial plus 2x to the third over 3 factorial minus 6x to the fourth over 4 factorial, and I'm not going to find the nth term yet, but that's coming shortly. So I don't need to write the 0. 1x is just x. I don't really need to write the 1 there. 2 factorial is 2, so that's the x squared over 2. 3 factorial is really 6, and 2 over 6 simplifies to 1 over 3. So that's x to the third over 3. And then 4 factorial is 24. 6 over 24 simplifies to 1/4. So that's x to the fourth over 4. And then I'll go ahead and do ... get my general term, x to the n over n, plus ... Okay, so I've got the 4 terms, I've shown them where they came from, I've got my general term. If you want to say that this works for n is greater than or equal to 1, you could, but it seems like typically they don't need that to get the points. Or n is greater than 0, you could say as well. So it just kind of, however you want to write it is fine, but I don't think they need that for you to get full points. I'd have to look back at the answer key. All right, part B. Oh, shoot. Forgot that it was alternating. Let me fix that. Not positive, alternating. I'm going to say, so we want the first term to be positive, so I'm going to say n plus 1 here. Whew, that was a near miss. Okay, so this is the alternating part, and then x to the n over n. Okay, part B. Determine whether the Maclaurin series described in part 8 converges absolutely, converges conditionally, or diverges. They gave you a clue in this problem because the only series test that tells you if it's conditional or absolute is the alternating series test. And so I'm going to go ahead, I'm just going to write this down so I can work with it. And it says for x equals 1, so if I plug in 1 for x, I've got -1 to the n plus 1 times 1 to the n. 1 to the n I don't really need to include. And then I have the n on the bottom. So I'm just going to write that this is the series that we're working with. And if we do the alternating series test, The first part of that test is to make sure the limit as n goes to infinity of everything but the alternating part, so I'll just put a 1 on top and an n on the bottom, that the limit as n goes to infinity of that is 0, which is basically saying, does it decrease? And the answer is yes. Will the absolute value of it decrease? And then the second question is saying, does it decrease through the numbers? So is the next answer less than or equal to 1 over n? That's true as well. So those are the two parts of the alternating series test. They both worked. So that means that it converges. We're just not sure if it's conditional or absolute. So if you guys recall to check to see if it's conditional or absolute, you just have to go over and consider the absolute value of this, basically. So you're taking away that negative and you're just saying, okay, what about this series 1 over n? Does that converge? This is divergent. It's actually the harmonic p series. And so that means that this series converges conditionally. And all of this work should be explanation enough of your reasoning. All right, part C says to write the first 4 non-zero terms and the general term, and it says g of x equals the evaluation from 0 to x of the integral of f of t dt. So we already have f of x, that's this stuff right here. So all you have to do is put this in an integral sign. You have to change it to t's though, because it says f of t. So put this in terms of t, and then integrate it and evaluate it from 0 to x. So it's not very difficult. It just is kind of weird looking notation when it asks you to do that. So I'm going to say g of x is the integral from 0 to x, and it's t minus t squared over 2 plus t to the third over 3 minus t to the fourth over 4. And did it want, and the general term, we're going to include all of that. Okay, so plus dot 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 negative 1 to the n plus 1, t to the n over n. Okay, so if I go ahead and integrate this, I'm going to have, this part is going to be t to the second over 2. This is going to be plus 1, so that's going to be an exponent of 3, and I'm going to divide by 3. So that's t to the third over, it still has the 2, but now it also has a 3 on the bottom. T to the fourth, it still has a 3 on the bottom, but now it also has a 4 on the bottom. T to the fifth, it still has a 4 on the bottom, but now it also has a 5 on the bottom. I'm going to go ahead, I'm keeping the coefficients, right? But now I've got t to the n plus 1, and I'm also dividing by n plus 1. And then that needs to be evaluated from 0 to x. Right, so this is my g of x right here. When I evaluated at x, I literally just plug x in, so that's very easy to do. X to the second over 2, x to the third over 6, x to the fourth over 12, x to the fifth over 20. You could have left those as 2, 2 times 3, 3 times 4, 4 times 5. It doesn't really matter. And then when I plug in 0, so I'm going to put plus dot dot dot, and then when I plug in 0, everything zeroes out. So I'm just subtracting 0 off the end. You probably don't even need to put that, to be honest. Okay, so there is our g of x. And now the last part is the error bound, of course. And so they said they're not telling you what degree. They're saying nth degree for now, but you're evaluating it at 1/2. And then they said to use the alternating series error bound, so that's nice, because that's the easier one. And they said p sub 4, so that means that they want the error of the 4th degree, which means that we're going to use the 5th degree when we calculate the error. So I don't know if we need to say this since they told us to use the alternating series error bound, but I'm going to say that the series is alternating and decreasing. And I'm just going to say that real quick because those were the two things you needed for the alternating series error bound, and I'm just being careful. So P sub 4 of 1/2 minus G of 1/2 is the error. That needs to be less than or equal to negative 1 to the 5th times x to the 5th divided by 4 times 5. And that needs to be less than 1 over 500. Okay, so this is kind of me writing out the formula for my error. I would start here before I plug in numbers because sometimes they give you a point for this. Just this setup right here and writing it down. All right, so I've got this. Negative 1 to the 5th is not going to do anything, so I'll just ignore that. Plugging 1/2 in, 1/2 to the 5th over 20. And you could leave it there, to be honest. But if you want to calculate it, just make sure that your numbers make sense. 2 to the 5th is 32, so you have 1 over 32 divided by 20. And so 32 times 20 is 1 over 640. So yeah, I'd say that definitely makes sense, that 1 over 640 is less than 1 over 500. If you don't feel comfortable with that computation, just scribble it out, and then they won't grade it.